Okay. Next speaker is Fabian. Title is Building a Data Preparation Pipeline with Pandas and AWS Lambda. Let's get started. Thank you.
Thank you. So yes, hello everybody. So yeah, my name is Fabian, and I will talk about building data preparation and processing pipeline with Lambda. So what you will learn in that session, at least I hope, is what is data preparation and why is it necessary. Then how you can do it with Pandas, and why it's a good solution to do it with Pandas. And finally, how to set up the pipeline with AWS Lambda. So just about me rapidly, I'm based in Tokyo. I'm a freelancer, software developer and consultant, working mostly on everything related to data products. So it goes from data visualization to machine learning. Recently, I've been also working on a project which is Denyoco.io, which is energy consumption and demand prediction API, because Yahoo is stopping its current API. So I'm trying to make something better instead of that. And it uses a lot of data processing pipelines everywhere, and that's related to the topic. So first, why data preparation? First question, how many of you here have been working with data in order to do some kind of reporting or some kind of data visualization? Okay, so maybe 30% of people. So yeah, typically, so what I'm going to talk about is that, so you've got some data. It comes from a survey. It comes from some CSV files that were gathered by someone, some sales report Excel files, and now you need to share it with an audience. And for that, you will make, it can be an interactive dashboard. It could be just a mail report, including some charts. It could be an interactive news article that includes some maps or some charts that help you understand and navigate the data. However, when you try to do that, one problem you will often face is that the data is not in a good state, and it's kind of messy. And it's often either incomplete, misformatted. It can contain also wrong values or corrupted values, and you will need to deal with it. And this is something that is quite common because often the data is just not available. Sometimes just the way it's collected is not appropriate, and a lot of mistakes get embedded in the data. It could be because of lack of validation, if you're using forms that are not checking for the type of the content, or that is not checking for categorical values, or just human errors. And this can have some bad consequences, because if you have a script that generates a report and the data is not the way it's supposed to be, it could crash if you are not careful enough when you made your script. Also, you could have some reports that are incomplete, or you could have some things that gives you data that are completely wrong, and you may want to try to get conclusions out of that report, but in fact, what you're showing is not related to the reality anymore. So it's really important to be careful here. So if your data is bad, whatever you do at the end, your result won't be that good. And also, so I'm talking about data preparation. It's not just about data cleaning. It's also about making it into a form that is usable for your end goal, which in my case is often visualization. That's why I'm talking a lot about reporting and things like that. So data preparation is about also enriching the data with so merging different sources of data. It can be aggregating because you have a lot of individual events, for example, but you want to group them into data for a week, for a month, for different kind of categories. And it can be applying some machine learning algorithm for classification or prediction. So this is one example of work I did this year, which was so with a team of journalists working in Turkey, and they were trying to report some information about a conflict that is happening right now between Turkey and independentist Kurds over there. And it was kind of an underreported event, and they have been trying to gather all the events related to everybody who is dying in this conflict. So they are gathering manually from sources on the field or from news article, and filling a huge compilation in a big file of everything that happened, trying to put all the context information on everything. And the problem is that those people are journalists and they are not at all programmers or not at all like they don't know how any script will work, and so they end up doing a lot of things that are quite annoying, like putting a comment in a data cell, having dates in different formats all over the place. So it requires a lot of cleaning if you want to be able to arrive to the end result, which is what you see on the right. And especially the tricky point is that, so it's okay when you do an analysis once and you just need to clean the data once. But often when you are dealing with something that like a product, it's data that should be updated regularly. Even in that case of that article, it's updated every few weeks with new data because the conflict is continuing. So it's not a static piece, it's something that's living. And when you need to run a script, yeah, someone has to run the script on. If it's not you, and I don't think it will be a journalist or it will be your sales team, or it's better to just automate everything, and that's why you will need a pipeline at some point. So today, my talk to kind of sum up what it applies to, I would say that when you're dealing with data and trying to do some reporting, there is a kind of scale of what is the quality of the data from really bad to really high quality, clean. And there's another scale that is update frequency. Which is the update frequency of both the data and the report in general. And also it varies from something where you do it once and you forget about it, or you do it every month, but maybe every day or even in real time. And what happens is quite often, applications where it's real time, the data is rather clean, because in order to have data available in real time, it means that you have already really really, how to say, like a really well thought out way to gather the data in real time. So it means that it should be maybe sensor data coming from a sensor where it's sending in real time to a platform. So everything is formatted, it's coming out of clean databases and everything. And on the other hand, when you're dealing on one-time things, it's likely that maybe you're merging different files from different sources that are in different formats, and that's where there's a lot of work to do. And the sweet spot for what I'm going to talk about today is a bit in the middle. You see, it's like when you have some data that is in not perfect condition, but still you will need to deal with it for a long time, multiple times, with some updates. And the interesting point is that Pandas is generally good on the left side of the spectrum, which is like a big amount of one-time data. And Lambda is more made for the right side of the spectrum, which is like recurrent use, event-based use, and maybe real time. And so you have a kind of a scope of different things that you may want to do. In the middle is exactly like data journalism, interactive reports, etc. And on the right is more like maybe the dashboard of your Fitbit health tracker. For them, the data is rather clean in general. So how to prepare the data? So preparing the data, it requires a lot of things. Like common things that you will need to do are date parsing, also finding strategies for all the missing data or data that you cannot parse in any way. And it's really important to decide, is it something we remove it or do we interpolate it? Then there's everything about value ranges. You just want to kind of dump-proof your solution because maybe somehow you have a field where it's supposed to be age of someone and you have an age of 230. Yeah, it's unlikely that you have someone who is more than 120 years old, so maybe you should remove that data. And also everything related to strings. It's often a hell to deal with, uppercase, lowercase, trailing spaces and everything. So you need to think about everything. And there are some tools that exist on the market. Most of them are free, and it includes like a three-factor wrangler, another solution. And most of them are focusing on data journalism or people dealing with open data for governments or those kind of applications. And it's really good because you just load your file and you will see automatically a kind of summary with a graph of the distribution of your data. Also, it will identify for you where there is something that looks like the data is not what it should be. So that's, for example, in the screenshot, you have some kind of a chart, and the red part indicates the proportion of your data that is not correct. And with those tools, you can generate some kind of scripts where you say, like, okay, if there is a missing value here, I want to drop the row. And then you can potentially reapply the same script on a different data set. So that's almost what we want, except that here we are mostly developers, and we know that Python is really powerful. And in fact, it's not that complicated to do things with Python. And those solutions that we saw before, like, they give you a lot of constraints. At some point, you'll reach a point where you cannot do what you want. So it's really good for data journalists themselves because it gives them a lot of power to deal with data, something that they couldn't do before. But for us as developers, I think it's a lot better to go straight to deal straight with the data. And Pandas is a superb tool that is getting mature now. So there was a talk about it just before. And it helps you deal with data frames, which is a format of data tables that is makes it easy to transform data, aggregate it, clean it. Just a question: who in the room has been using Pandas in the past? Okay, not maybe 30% again, a bit less. So I won't go into the detail of Pandas today. I will show some simple samples, but I'm not here to teach you how to use it. Just want to show you that you can do powerful things with it. So that's a kind of simple example where I'm loading a simple file that contains a list of persons. On each of those persons, they have a name and they have an age. So loading the data with the Pandas is as simple as doing a read CSV, and you load the file and you can check out the head, which is just the first lines of that data set. So as we see here, everything looks fine. People seems to have normal ages, normal names. Then let's try to do some interpretation of that data. So for example, one question we may have, is there a relation between the length that people are giving, of names that people are giving to their children, and maybe how old are those people? So it means like during time, there's a trend of using long or short names. So what you can do with Pandas is easily a chain operation. So I define one function that will compute the length of one element in the table, which is that name length function. And then I create an aggregate function that will so group by, so take all the samples that have the same name, and for them like extract the name length, and for them extract the different metrics on the age, like the median, the average, the maximum value, etc. So just that piece of code, and then I plot it, and I see, so at the bottom it's the median age, and on the side is the length. So I see that I have an outlier, I have some warning here, so some bad signs. I need to check a bit more the data. And indeed, something is wrong. Like if you start to check, you can check, for example, the count of each unique values in a column. So for example, here in the name column, I'm checking how many times each value appears, and I start to see that there is multiple times. I see Jack twice, or 3 times even. Ichiro appears also 3 times, because as you can see, there's some issues with the case, trailing spaces. So my algorithm was completely wrong. I can also do some simple description to see a bit what's inside the data. And we see that there is some issue for calculating the quantiles, and this is because some values are null, are not numbers, and so the Pandas is not able to calculate a proper value. So we need to fix those things. So first thing to do is like dealing with missing values, and for that you have powerful features in Pandas which are drop NA, which means that you will remove all the rows, or you could also remove columns who contain one or more null values. You can also fill them using different kind of patterns. It can be like copying the same as the previous values, interpolating, etc. And we also like decide to reject outliers. For example, I will remove the people who have an age above 120, and then I can simply like define a kind of pipeline where I apply different operations on my data frame, one after the other, which give me the kind of cleaned output, which is the result I want. And as you can see in the table now, that's after aggregation. There is no more issue. Everything is filled properly. No values that you don't expect. on when plotting the chart. So maybe the data is not that exciting because it's something I created manually just as a sample. But we can see maybe that there is some correlation. So we have a result. And so one thing that is really important when you do those things is to document properly what you're doing, and also report all the errors you find, because often like some of the errors can be really easy to avoid. For example, let's say like the person you are working with is using Google Spreadsheet, and now in Google Spreadsheet you can define a column type that can be an integer, and this way you will be sure that nobody will ever enter some misformatted string in it. So if you increase the feedback loop between your processing and the people who are inputting the data, it's an opportunity to add some defenses and to attack the problem at the root and not fix it later when it's too late. So ideally, it's good if you can test your preparations, and that's why you need to be careful, because often when dealing, so earlier I was showing you a sample using IPython notebook, Jupyter. And it's kind of easy to get in the trap of starting to type a lot of code one after the other, and never really using functions and forgetting about clean code. So please don't fall into that trap. And that's why like unit testing, also your sub-processing unit, can be a really good idea. And one framework that I found recently that seems really interesting for that is Hypothesis. It lets you define the type of input that you expect, and it will automatically run your unit test with different kind of inputs, and which is really good to make you detect some errors that you didn't even think about. And if you want more reference about data cleaning, I will share the slides later, so you don't need to write down the URLs, but there are some very good talks, the two first ones about data cleaning with Pandas and without Pandas, and full of resources, because Python is really rich ecosystem in that, and many things that you can do. So now the last part of that talk is about setting up a pipeline with AWS Lambda. So who in the room has used Lambda in the past? Okay, a few people. What about Google Cloud Functions? Well, just 3 people. So those technologies are kind of new technologies. The new like serverless technologies that are really interesting because they help you not manage servers, in fact. The thing that you define just functions that are simple piece of code that are triggered by an event and makes an output, and that's it. Which means you don't need to manage the life cycle of a server. You don't need to think about the scaling. It can be handled automatically, and you pay only for what you run. On AWS, you pay by 100 milliseconds. So if you have a function that is triggered a few times a month or a few times a week, you will end up paying just a few cents. It's like nothing. And why is it important? Is that, so as you saw earlier, sometimes when you deal with this kind of thing, you don't want to let some people run scripts, especially it's another place where you could mess up. And we are talking about data quality earlier, so let's automate. And we want to keep things simple and cheap if possible, and that's why serverless is really good for that. And getting started with AWS Lambda on Amazon is really easy. You can do, of course, everything with on the command line once you know what you're doing. But to get started, you can just, in a few clicks, create a function. And as you see in the bottom, a function is just a Python function that takes 2 arguments. The first one, event, being the call parameters. And the second one, the context, being just some information about the time where it was triggered, the name of the function, the version of the function, those kind of other information. And you have a few parameters that you can change, which are, in particular, the interesting one is the one about memory. You can go up to 1.5 gigabyte. And in fact, the CPU power will be also matched to the memory available. So it lets you, with that kind of size, 128 megabytes, you can already run some simple scripts that use Pandas if your data set is small enough. And there is no particular issue. And then the fun point of it is that you can create some kind of architectures, also with kind of few clicks. So it depends also how much you are using AWS. But you can easily plug it to the different services. And what is interesting, as far as I'm concerned, is especially event scheduling, which means that you have available a cron system that is autonomous and stable. So you can have something that is purely autonomous, one cron, one Lambda function, and your script will run automatically every day, every hour, every month. And second way to work with it is to make an API on top of it, which can be used as a webhook, for example. And it's really interesting. For example, in the previous project I was showing, my client was filling data in a Google spreadsheet, and when they think the data is okay, they want to update, you did a small button, they click update data, and the Lambda function is called, fetch the new data, process it, update to an FTP, and it's finished. However, that's where it's a bit less fun, is that if you want to use Pandas on Lambda, it's a bit tricky because the way Lambda works, all your dependencies, you are not installing them with pip or conda. You need to bundle them with your application. And every time you have something that is requiring external C compile libraries, you need to make them ready for Amazon Linux AMI. So Linux Amazon version of Linux. And so the easiest way to do it is to launch an EC2 instance on Amazon. And on it, you will install all the tools that you are required to install Pandas. You install Pandas, you zip up everything, and then you get that zip on your local computer. I won't go into detail of the script, it's boring. And then once you want to use the function, so you need to define it, and there's another issue, because now, especially, we have had to export some some libraries, so Linux libraries, SO files. So we need to add them to the environment path. And since you don't have access the way Lambda is working, that it just launches your code as seen in the file that you updated, and you don't have any control on the like execution environment. It's their Python 2.7 that is launched, and that's it. But what you can do, you can trick a bit around that, because in the end, what is available behind is a standard EC2 instance. So in fact, you can open a process and open a new and launch a new Python instance for which the proper environment variables are available, which means that you start to have some freedom, and you can, in particular, work with Pandas. And then, which means that so here, what's happening is that so the Lambda handler at the bottom is a function that will be called by AWS. And here we have the handler function that takes as an argument your other function that the one you really want to launch, and will launch that one in a sub-process and return the result. And that's the proper function that is using Pandas, will be that other file, in which so you can do now whatever you want, since you are now free. So in that example, for example, I'm loading data from Google spreadsheet, decoding it, putting it in a data frame. Then we do something with it, and at the end, I write the output to a file, and I can copy now that file on S3. I can copy it on FTP. And that's finished. And that would be a typical use case of a data preparation function on Lambda. One thing I forgot to mention is that you see the first line is the run, like the event with the pickle. In fact, those call arguments, I couldn't also pass them directly with the sub-process. So in that case, one solution, there might be other solutions. I'm not a process expert, is to copy it to the disk temporarily. You copy the kind of JSON file that contains a few arguments, and you load it again in the Python, in the other Python process. And once you are done, so you package that function with the zip that you created earlier with the Pandas environment, and now you are ready to launch. Just a few things to be careful about. First, it's using Python 2.7. Right now, I think Amazon decided that it was the language that was used the most right now. So they choose to use Python 2.7. However, Python 3 is available on the machine. I saw some people, you can check the details, who also using that kind of sub-process technique managed to run code using Python 3. So it's doable. And also, I hope that maybe in the coming months, or at least next year, Python 3 will be supported by Lambda directly. And second thing to be careful about is the execution time limit. You can set it up, but there is a maximum running time, I think around 1 minute. And the process memory. So if your dataset is really big, you may need to split it and find yourself a solution to parallelize the computation, which can be easy to do because yeah, Lambda functions are cheap to run and easy to trigger. And what else? Yeah, that's it. And if you have more really complex computations that even when splitting your database, your data file, it doesn't work, you need to break your pipeline into multiple functions that you call one after the other. And to share the result, if your result is big enough, you'll probably need to store it on some database or some file somewhere. Okay, so just to sum up, so a few important things I think is, so you need to know your data and where it comes from and what you want to do with it. It's always the main thing. Then pandas can be really helpful and you can sort out most of the issues with it. Then think about defensive programming, like think about all the potential use cases before the API if possible. But then on the other hand, also try to fix the data at the source and not at the end. And finally, yeah, Lambda I think is really a powerful technology that is really practical now, especially for small teams in startups when you don't want to have any DevOps cost, when you don't want to pay for expensive servers. That can really solve a lot of problems. Thank you. So if you have any question.
If you have any questions, okay.
Thanks for the talk. Can you explain a little bit why you had to use Lambda? You didn't really explain what the use case here is.
So why Lambda? Because I want to have my script, this is preparing the data. I want it to be running every time someone is updating the data. However, those people who are updating the data, they are not developers. So I have that script somewhere that needs to run. And I don't want to be called and run it all the time also.
So it's like a lot of people are posting data like one after another.
Yeah, they do it like every, I don't know, sometime when they have new source of information. But it can be many things. It can be, another example would be like you have some people in maybe more traditional companies doing sales reporting on Excel files. And they do it every week or every month, and it's a bit messy, there may be some input. And also they want to update it, so maybe they will just put it on a shared, on a Dropbox, for example, and then you trigger a webhook, and it can trigger the processing on Lambda. And for me, the whole point about Lambda is that it's cheap, it's really easy to deploy. See, I don't want to create a server with Django or Flask just to listen to a webhook. I don't even want to do that if possible. So this way I can just focus on the processing code only, and that's all I have to do.
So in your specific use case, you had a case where a lot of people are doing manual work or
yes.
data, and you wanted to deal with that as they come in.
Yes, exactly. But just to finish, if you had even like some more automatic use cases, it could be useful also. It can be triggered from a new database input. Then it's not about cleaning the data, but it can be still about doing some machine learning on the data. I think that Lambda technology is really interesting for many things. Every time you have some event-based processing to do.
Thanks for your talk. I have a small question. When you run your Lambda function, you may have some data errors. How do you debug the process, and how do you trigger again your Lambda function after that?
So yeah, Lambda is a bit dumb on this side. So what you can do, you can you can store logs on AWS. So there will be some log output, and then one thing you could do, for example, kind of smart way to reuse Lambda, that you could have another Lambda function that gets triggered every time there is a new error in a log, and that will do what needs to be done, and that's really depending on your application. But there is no like retrial system included with AWS Lambda. It's up to you to do the thing.
Okay, so you have to read your logs. Do you receive some emails or something else?
Yes.
To be notified and there is an error? No.
Yeah, you can get notified from the logs or this kind of thing.
Okay, thank you.
Any questions? Okay. Thank you very much.
Thank you.